This is SpaceTime Series 28, Episode 1, for broadcast on the 1st of January 2025. Happy New Year! Coming up on SpaceTime, the Webb Space Telescope confirms Hubble Tension, in the process challenging existing cosmic theory. A new hypothesis to explain how liquids could erode out gullies on the surface of the airless asteroid Vesta. And it's New Year's Day on Earth, but it seems the real fireworks are happening on Mars. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
New observations from the Webb Space Telescope suggest that a new feature in the universe, and not a flaw in telescope measurements, could be behind the decades-long mystery of why the universe is expanding faster today than what it did during its infancy billions of years ago. The new Webb data confirms Hubble Space Telescope measurements of distances between nearby stars and galaxies, in the process offering a crucial cross-check to address the mismatch in measurements on the universe's mysterious expansion. Known as the Hubble Tension, this discrepancy remains unexplained even by the best cosmological models. In fact, the more accurate the observations are, the wider the gap seems to be. The discrepancy between the observed expansion rate of the universe and predictions according to the standard model suggests that science's understanding of the universe must be incomplete. The study's authors Adam Rees and Thomas Barber from the Johns Hopkins University say the two NASA flagship telescopes, Webb and Hubble, now confirm each other's findings, and astronomers need to take this Hubble tension problem very seriously. The new research, reported in the Astrophysical Journal, builds on Rees's Nobel Prize-winning discovery that the universe's rate of expansion is accelerating owing to a mysterious force, which astronomers call dark energy, which is permeating vast stretches of space between stars and galaxies. Understanding dark energy will not only provide a more complete picture of the universe, it'll also tell us what our ultimate fate will be. Will the universe eventually stop expanding and start contracting under gravity, eventually ending in a big crunch? Or will the rate of expansion simply slow down in the long term, eventually reaching a steady state? Based on our limited understanding of dark energy, both these options have been ruled out. And that leaves two more possibilities, the Big Freeze and the Big Rip, neither of which are especially appetizing. The Big Freeze will see the universe expanding forever. Eventually, all the stars we see in the night sky will be beyond the cosmic horizon, and the universe will appear empty, leaving us alone in the cosmos. But a far more disturbing possibility is that the rate of accelerated expansion will continue to increase. Eventually, not only will galaxies move away from each other's line of sight, but stars within the galaxies will move away from each other as well. And as the strength of dark energy continues to increase, ultimately, even atoms will be torn apart, with the final act seeing quarks ripped apart from their gluons. This is the Big Rip. So, understanding dark energy in the Hubble tension is important for understanding the ultimate fate of our universe. To try and get there, Rees and colleagues have been using the largest sample of Webb data collected over the first 2 years of its operations. This allowed them to verify the Hubble telescope's measurements for the expansion rate of the universe, a number known as the Hubble constant. They used 3 different methods to measure distances to galaxies that hosted supernovae, focusing on distances which had previously been gauged by the Hubble telescope and known to produce the most accurate local measurements of this number. And the observations of both telescopes align closely with each other, revealing that Hubble's measurements are accurate and ruling out any possibility of an inaccuracy large enough to attribute the Hubble tension to simply an error. Still, the Hubble constant remains a puzzle because measurements based on the telescope's observations of the present universe produce higher values compared to projections made using the standard model of cosmology, a widely accepted framework for how the universe works, calibrated with data from the cosmic microwave background radiation, the faint afterglow of the Big Bang itself 13.8 billion years ago. The standard model of cosmology yields a Hubble constant of around 67 to 68 kilometers per second per megaparsec. while measurements based on Hubble telescope observations and our observations using Webb give far higher values of between 70 and 76 kilometres per second per megaparsec, with 73 kilometres per second per megaparsec being taken as the average. Now, this mismatch has perplexed cosmologists for well over a decade because a 5 to 6 kilometres per second per megaparsec difference is simply too large to be explained by flaws in measurements or observational techniques. By the way, a megaparsec equates to 3.26 million light-years, a parsec itself being 3.26 light-years, and a light-year being approximately 9.4 trillion kilometres, the distance a photon travels in a year at the speed of light, which is 300,000 kilometres per second in a vacuum. Rees's team suggests that since Webb's new data rules out significant biases in Hubble's measurements, the Hubble tension may stem from unknown factors, gaps in cosmologists' understanding of the physics of the universe. This new study covered roughly a third of Hubble's full galaxy sample, using the known distance to a galaxy called NGC 4258 as a basic reference point. Now, despite the smaller data set, the authors achieved impressive precision, showing a difference between measurements of under 2%. That's far smaller than the approximately 8 to 9% size of the Hubble tension discrepancy. In addition to their analysis of pulsating stars called Cepheid variables, the gold standard for measuring cosmic distances, the team cross-checked measurements based on carbon-rich stars and the brightest red giants across the same galaxies. All galaxies observed by Webb, together with their supernovae, yielded a Hubble constant of 72.6 kilometres per second per megaparsec, nearly identical to the value of 72.8 kilometres per second per megaparsec found by Hubble for the very same galaxies. The combined measurements make for the most precise determination yet about the accuracy of the distances measured using the Hubble telescope's Cepheid stars, which are fundamental for determining the Hubble constant. The Hubble constant reveals the evolution of the universe on extremely large scales, with vast areas of space itself stretching and pushing distant galaxies away from one another, sort of like raisins in a raising dough. It is a key value scientists use to map the structure of the universe, deepen our understanding of its state 13.8 billion years after the Big Bang, and calculate other fundamental aspects of the cosmos. Resolving the Hubble tension could reveal new insights into more discrepancies with the standard cosmological model which have come to light in recent years. Now, the standard model basically explains the evolution of galaxies, the cosmic microwave background radiation from the Big Bang, the abundances of chemical elements in the universe, and many other key observations based on the known laws of physics. However, there are lots of things it doesn't do. For example, it can't explain the nature of dark matter or dark energy, two key mysterious components of the universe which are estimated to be responsible for 96% of its makeup and accelerated expansion. Now, the authors think one possible explanation for Hubble tension could be that there's something missing in our understanding of the early universe. Possibly some new component of matter, a sort of early dark energy that gave the universe an unexpected kick after the Big Bang. Other ideas include funny dark matter properties, exotic unknown particles, changing electron masses, or primordial magnetic fields. But all of these are just hypotheses. This is SpaceTime. Still to come, how liquids could carve out gullies on the airless surface of the asteroid Vesta, and tracking New Year's Day on Mars. You think Earth's New Year's celebrations are something? That's nothing compared to what the red planet gives us. All that and more still to come on SpaceTime. Pocked with craters, the surfaces of many celestial bodies throughout our solar system provide astronomers with clear evidence of a 4.6 billion-year battering by meteoroids, asteroids, comets, and other space debris. But on some worlds, including the giant main-belt asteroid Vesta, which was visited by NASA's Dawn spacecraft, the surface also contains deep channels or gullies, and the origins of those are not fully understood. One hypothesis holds that they were formed by dry debris flows driven by geophysical processes such as meteoroid impacts and changes in temperature due to exposure to the sun. However, a new study reported in the Planetary Science Journal provides some evidence that impacts on Vesta may have been triggered by a less obvious geological process, namely sudden and brief flows of liquid water that carved out gullies and deposited fans of sediment. The new ideas are based on lab experiments designed to mimic conditions on Vesta. The the NASA study detailed for the first time what liquid water could be made to do and how long it would flow before freezing. Although the existence of frozen brine deposits on Vesta is unconfirmed, scientists have previously hypothesized that meteoroid impacts could have exposed and melted ice that lay frozen under the surface of worlds like Vesta. Now, in that scenario, flows resulting from this process could have eroded or etched out gullies and other surface features which resemble those seen here on Earth. The problem is no one's quite worked out how a celestial body which doesn't have an atmosphere and is exposed to the intense vacuum of space could host liquids on its surface long enough for them to flow and erode away part of that surface. See, such a process would run contrary to our current understanding that liquids quickly destabilize in a vacuum, sublimating directly from a solid ice to a gas when the pressure drops. One of the study's authors, Jennifer Scully from NASA's Jet Propulsion Laboratory in Pasadena, California, says the new experiments show that not only can impacts trigger flows of liquids on the surface, but these liquids do remain active long enough to create specific surface features. She says most liquids become unstable quickly on these airless bodies, where their vacuum of space is unyielding. But it turns out the critical component to change all this is sodium chloride, in other words, table salt. The experiments showed that on conditions like those seen on Vesta, pure water would freeze almost instantly. On the other hand, briny liquids stayed fluid for at least an hour. And that's long enough to form the erosion flows associated with features identified on Vesta, which are estimated to require at least half an hour. Launched back in 2007, NASA's Dawn spacecraft travelled to the main asteroid belt between Mars and Jupiter and orbited Vesta for 14 months before moving on to the dwarf planet Ceres, where it orbited for another 4 years. Before ending its mission in 2018, scientists uncovered evidence that Ceres had been home to a subsurface reservoir of briny water and may still be transferring brines from its interior to its surface today. The study's lead author, Michael Poston from the Southwest Research Institute in San Antonio, Texas, says the new research offers insights into the processes on Ceres, but focuses also on Vesta, where ice and salts may produce briny liquids when heated by an asteroid impact. To recreate Vesta-like conditions that would occur following a micrometeoroid impact, the authors relied on a test chamber at JPL called the Dirty Under-Vacuum Simulation Testbed for Icy Elements, or DUSTY for short. By rapidly reducing the air pressure surrounding samples of liquid, they mimic the environment around fluids that flowed onto the Vesta surface. Exposed to vacuum conditions, pure water froze instantly. But salty fluids hung around much longer, continuing to flow before freezing. Now, the brines they experimented with were just a few centimetres deep, while the flows on Vesta were metres to tens of metres deep, and so would have taken even longer to refreeze. The authors were also able to recreate the lids of frozen material thought to form on top of the brines. Now, essentially, a frozen top layer, the lids, stabilise the liquid beneath them, protecting them from exposure to the vacuum of space, or in this case, the vacuum of the dusty chamber, and helping the liquid to flow longer before freezing again. This phenomenon is similar to how on Earth lava flows further inside lava tubes than what it does when exposed to cool surface temperatures. It also matches up with modelling research conducted around potential mud volcanoes on Mars and volcanoes that may have spewed icy material from geysers on the Jovian moon Europa. Scully says these results contribute to a growing body of work that uses lab experiments to better understand how long liquids last on a variety of worlds. This is SpaceTime. Still to come. You think New Year's Eve fireworks on Earth can be spectacular? That's nothing compared to what happens on Mars. And later in the science report, a new study shows that artificial intelligence may be able to identify people simply based on how they walk. All that and more still to come on SpaceTime. New Year's Eve celebrations on Earth usually include fireworks. But that's nothing compared to what happens on the red planet Mars. Right now, the Martian northern hemisphere is going through an active, even explosive spring thaw. The red planet completed its trip around the Sun on November the 12th, prompting a few researchers to raise a toast. But the Martian year, which is 687 Earth days long, ends in a very different way to what we experience here on Earth. While planet Earth's northern hemisphere is going through a winter wonderland, the Martian northern hemisphere is seeing rising temperatures and ice thawing, leading to frost avalanches crashing down cliffsides, carbon dioxide gas exploding from the ground, and powerful winds helping reshape the red planet's north pole. Serena Deniga from NASA's Jet Propulsion Laboratory in Pasadena, California, says on Mars the spring happens with a bang. The red planet's wispy atmosphere, which is just 1/99th the atmospheric pressure of Earth's, doesn't allow liquids to pool on the surface like it does here on Earth. Instead of melting, ice sublimates, turning directly from a solid into a gas. And this sudden transition in spring means a lot of violent changes as both water ice and carbon dioxide ice, which is much more plentiful on Mars than frozen water, weakens and breaks. That means lots of cracks and explosions instead of melting. Using the cameras and other scientific instruments aboard NASA's Mars Reconnaissance Orbiter spacecraft, scientists studying the Martian spring have been seeing some dynamic surface changes. In 2015, the probe's high-resolution imaging science experiment camera captured a 20-metre-wide chunk of carbon dioxide frost in freefall. Deniga says chance observations like this are reminders of just how different Mars is from Earth, especially in springtime when the surface changes on the red planet are most noticeable. Another quirk of the Martian springtime are gas geysers, which blast out of the surface, throwing out dark fans of sand and dust. See, as the sunlight shines through the ice, its very bottom layers turn into a gas. That gas continues to build and build pressure until it eventually bursts through the ice and into the air, creating dark fans of material. But to see the best examples of these fans, researchers will need to wait until December this year. That's when spring starts in the Martian southern hemisphere. There, the fans are bigger and far more clearly defined. Once all the ice around the northern geysers is sublimated in summer, what's left behind in the dirt are scour marks that, from space, look like giant spider legs. For Isaac Smith from Toronto's York University, one of the most fascinating subjects in springtime is the Texas-sized ice cap at the Martian North Pole. Etched into the icy dome are swirling troughs, revealing traces of the red surface below. He describes this effect as looking a lot like a swirl of milk in a cafe latte. Smith says the swirls are enormous, some as long as California. Now, you can find similar swirls in Antarctica here on Earth, but nothing on the scale of Mars. It seems fast, warm winds carve out the spiral shapes over eons, and the troughs act as channels for springtime wind gusts that become more powerful as the ice at the North Pole starts to thaw. Just like the Santa Ana winds of Southern California or the Chinook winds of the Rocky Mountains, these gusts pick up speed and temperature as they ride down the troughs in what's called an adiabatic process. The winds that carve the northern pole's troughs also reshape Martian sand dunes, causing sand to pile up on one side while removing it from the other. Now, over time, this process causes the dunes to migrate, just as wind does with sand dunes here on Earth. Last September, Smith co-authored a paper detailing how carbon dioxide frost settles on top of the polar sand dunes during winter, freezing them in place. Then, when the frost all thaws away during the spring, the dunes begin to migrate again. Deniga says each northern spring is a little different, with variations leading to ice sublimating faster or slower, controlling the pace of all these phenomena on the Martian surface.
Here on Earth, we're entering the new year. We've also entered the new year on Mars. And with the change of seasons, Mars has a lot of great activity. Avalanches, creeping sand dunes, exploding jets of gas that may even create some spiders. The Martian New Year happened in November, and my friends and I got together to celebrate. While it's winter here at NASA's Jet Propulsion Laboratory, the Martian New Year starts in springtime in the Northern Hemisphere. Increased sunlight warms up that winter ice, which is mostly frozen carbon dioxide, which you probably know as dry ice. So one of the ways that we can track the springtime changes on Mars is with NASA's Mars Reconnaissance Orbiter, or as we call it, MRO. As MRO flies over the polar regions, it can study the polar ice cap, which grows in the fall and winter, and then retreats in the spring. Increased sunlight in the spring warms up that winter ice, causing large avalanches near the North Pole. Ice and dust chunks from the cliff sides plummet down the slope. Springtime warming also wakens sleeping giants. Surrounding the North Pole of Mars are sand dunes that get completely covered with ice. As that ice is removed in the spring, winds are able to reach the surface, allowing the sand and the dunes to move forward again, as dunes have been doing on Mars for millions of years. Springtime also brings a very un-Earth-like process, forming exploding jets on Mars. Carbon dioxide ice does not melt like water ice. Instead, it goes from solid straight to a gas. On Mars, the seasonal warming causes that ice to vaporize, but from the bottom of the ice slab, high-pressured gas builds up until it's able to explode out in a high-pressured geyser, spewing gas and sand and other materials onto the surface. Additionally, that gas as it escapes sometimes carves tracks into the Martian surface. In the southern hemisphere, we see giant branching patterns of these tracks, which in the MRO images look an awful lot like spiders. So these are just a few of the active changes that we see on Mars as it enters into its new year. Using images from spacecraft, we can track and compare these changes year to year, helping us learn more about our planetary neighbor and its exciting seasonal cycles.
That's Serena Deniga from NASA's Jet Propulsion Laboratory in Pasadena, California. And this is SpaceTime. And time now to take another brief look at some of the other stories making news in science this week with the Science Report. A new study shows that teen smoking doesn't just increase the risk of heart disease later in life, it causes early and lasting damage to heart muscles and their function. A report in the Journals of the American College of Cardiology analysed data from 1,931 adults using complete records of smoking and heart scans at age 24. They found that tobacco smoking from age 10 to 24 was associated with a 33 to 52% higher chance of premature structural and functional heart problems. It was also associated with an increase in heart mass, even after controlling for other risk factors. The authors say the increase in heart mass in just a few years of smoking should convey just how dangerous the consequences of smoking are for people who continue to smoke from a young age. Scientists are calling for urgent action to protect the highly endangered Palmer wallaby. Researchers from the Australian National University are recommending the creation of more fox-free safe havens and greater collaboration between government and landowners in order to ensure the survival of this rare endangered species of wallaby. A report in the journal Australian Zoologist warns that the Palmer wallaby, also known as the white-throated wallaby, is listed as a vulnerable species in Australia, while the International Union for the Conservation of Nature classifies it as near-threatened. The rare marsupial is only found along the Great Dividing Range in northern New South Wales. A new study has shown that artificial intelligence may be able to identify people simply based on the way they walk. And that could be opening the door one day to using your distinctive swagger as part of home or airport security systems, or to help confirm the identity of criminal suspects. In totalitarian countries, it could also be used to identify people who have covered up their faces with surgical masks and dark sunglasses in order to avoid facial recognition systems. A report in the journal Interface claims scientists trained AI models on over 700 people from different countries walking on pressure pads to measure the unique forces applied to the ground while walking. They found that the AI model's ability to recognize people based simply on their walk ranged from 52 to 100% accuracy, with factors like footwear, walking speed and body mass all playing a role in the way people walk. Australia's Therapeutic Goods Administration approves AirPods Pro 2s for use as hearing aids, and we take a look back at the biggest tech flops of 2024. With the details, we're joined by technology editor Alex Zaharov-Reutt from TechAdvice.life.
Yeah, this is the AirPods Pro 2. And look, already if you had AirPods Pro, you were able to activate a conversation mode that would more readily send the voice of somebody speaking to you, like a waiter at a cafe, and you could hear it more clearly. And I did help friends to set that up. But this actually turns the AirPods Pro 2 into therapeutic grade hearing aids. Now, this was already activated in the US, but this will require a software update, which will come over the next couple of weeks. They've been approved as devices adjusted by the user to meet their hearing needs with perceived mild to moderate hearing impairment. So look, for $3.99 Australian dollars, obviously a little bit less than US dollars, but the value is more or less the same once you add the tax, you get hearing aids that compete with ones that cost at least a couple of $1,000s to a lot more. And one of the cool things about the AirPods, of course, is they're inexpensive, they're quick to charge, they fit in your pocket, you can have one or you can have both.
And of course, the other big news is the trends year on year. What's happening in terms of technology?
Yeah, look, there's going to be a number of these predictions for 2025, but an interesting article I found at TechRadar was ranking the biggest tech flops of 2024. The least interesting of the flops was the GoPro Hero 2024. This was supposed to be compact, cheap, and dead easy to use, but it fumbles the ball in terms of its image quality, according to TechRadar. Something is called the EV Ring, EVIE. It was meant to be a smart ring with a woman-first design.
What did it do?
So the EV Ring boasted, according to TechRadar, a bunch of traditional functions, sleep tracking, heart rate monitoring, but it stumbled, they say here, in its execution. The menstrual tracking was very basic. The activity tracking features are basic. Sleep functionality doesn't seem as good as the competitors can do. Number 9 was Windows Recall, the feature that allowed you to search through everything on your computer because of screenshots that it took every few seconds.
Nobody wants Big Brother to have that access.
Microsoft still, they've delayed it and they've delayed it again and again. The new Sonos app was a big failure. They basically had to revert back to the old one because people were very upset with the new one. Sonos is the wireless speaker system that allows you to play the same music on all the different speakers in the house at the same time, or have different speakers playing different music in different rooms and control it all from an app. And they were pretty much the first to do this in a smart app kind of way with wireless speakers that, you start to plug into power, but they connect it to your network wirelessly. The new app was meant to make things simpler and better, and it's one of those instances where everybody clamored for the old app. Now, there was also, at number 7, a game called Concord. This was a game that just didn't work properly. People really thought it was cringy. The sales were weak on the PS5 and on the PC. The servers were shut down within a couple of weeks. People were refunded. So when a game fails and flops so spectacularly, that is definitely one that's going to end up on your list. Then there was, according to, again, TechRadar, number 6 was Windows 11 24H2. So that was the version of Windows that was for the second half of 2024, but they had a lot of bugs, which of course annoyed people, small bugs, big bugs, strange bugs for PC gamers. And the short version is that we're often told you should update straight away because you fix vulnerabilities, but major operating system manufacturers, of which there are only a few, I mean Microsoft being one of them, they need to be testing these things on as many different configurations as deeply and as widely as possible. And that's why they have the insider builds, but clearly this was a big failure. Now, number 5 was AirPods Max 2024. Now, the original AirPods Max, these are the ones that go over your ears, like a Bose or a Sony pair of over-the-ear headphones. They were launched in 2020, and they got really good reviews for that time. And what was meant to happen was that this year we were meant to get AirPods Pro Max version 2. But instead, what we got was an AirPods Max with a USB port. So it was exactly the same version as before, but its charging port was switched from Lightning to USB. So people were very upset about that. Number 4 on the list was the Rabbit R1. So this was meant to be a companion device that was like half the size of a mobile phone. That was your AI companion. It could do things for you. It could do things in apps for you. You could order Ubers. You could do these various things which people said, well, hang on, can't I just do that through the ChatGPT on my phone? Or, why do I need an app to order an Uber for me when I can just do it myself? I mean, I just push a couple of buttons. And it was one of these devices that was trying to sell itself as an AI companion, but it flopped. It couldn't even tell you the weather properly. People were very disappointed with it. And somebody realized that you could hack it, extract the software from it, and just run it on any Android. So it was a hardware device that was running an Android app. And after the initial flurry and people got the devices, it flopped and it failed and people hated it. Then number 3 on the list was Spotify Wrapped 2024. And now this is meant to be a look at what people listen to most over the year. But according to TechRadar, there was something of an explosion of bad feeling around Wrapped this year. And the reasons were that there was a lot of AI features that were overplayed. There were fewer stats about your top tunes, and there was data that was missing on the top genres and albums that people were playing relentlessly. So this was a top of the pops type list that delivered less information than in previous years, and nobody liked it. Then number 2 was a cousin, as it were, to the Rabbit R1. This was a pin that you wore on your lapel, a little bit like, a Star Trek communicator. And the Star Trek communicators were all activated by voice. You were talking to other people. This device was actually beaming information via a laser into your hand. So you held your hand and you could see weather reports, or you could see arrows to turn left or right. And you could also then talk to the device and ask it various questions. And it was meant to be like a Star Trek style communicator blended with AI on steroids. But when it came out, it didn't work very well. The handheld controls to control it were fiddly. The screen got sort of washed out in bright sunlight. I mean, it was an attempt that flopped, and then the company wanted to sell it off. And so that failed. And again, this is technology over-promising and under-delivering. But the number one product that TechRadar said was the biggest flop of 2024 was the Apple Vision Pro. Now, this is a bit unfair because I've put on an Apple Vision Pro, and it is stunning. You can get this incredible, massive wraparound display of your MacBook screen floating in midair. You can have multiple apps floating in midair. You can have apps pinned to different parts of your house. So when you walk in, there's TV screens, there's apps all sitting there in that area waiting for you. But the big problem with it was that it's heavy. It's heavy and it's large. And after about 20 minutes, I could feel the weight on the front of my head. So a lot of people said that the Vision Pro was a dev kit rather than a product for sale. But because people say on the internet, because of the failure of the Apple car, Tim Cook needed something to sort of rally the troops. And whilst the rest of the world was working on AI solutions, Apple was wasting years working on the Apple car, and then this headset, which was years from becoming something that was affordable and that people could be happy to put on. In this same year, we saw the Orion project from Meta, from Facebook, which looks like a pair of Ray-Ban glasses, a little bit thicker, but not much. And that looked like something that was the future. Not these ski goggles you put on with this giant band around the back of your head that was heavy after 20 minutes and cost $5,000 or $6,000. So clearly these headsets, definitely, these augmented reality headsets definitely are the future, but it needs another good 5 years of development and improvement. So that was the biggest flop
Needs to be
of
miniaturized.
2024. Needs to be miniaturized. Like with most tech, needs to be miniaturized.
That's Alex Zaharov-Reutt from Tech Advice Start Life. That's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.